Today we're going to talk about the derivative, but we're going to talk about the general derivative. So before we talked about f prime of 2 and what that meant and what that looked like, but today we're going to talk about f prime of x. And so this is the section is called the derivative as a function. And so the idea being that if you have a different a curve, say this is y equals f of x, depending on where you are on the curve, in other words, depending on what your x value is, the derivative will change. Be based on thinking about the pictures, the derivative of the tangent lines. So over here, we have a tangent line that has a slope. It's positively sloped. Here, it looks like we have a horizontal tangent line. Here, it looks like we have a negatively sloped tangent line. So if we were to collect all those values of all those slopes, that becomes the data, if you will, of your derivative function. And we're going to learn as time goes on how we can actually figure out what this looks like in general, not just with data values. But for now, we want to be thinking about these as slopes of tangent lines. So slopes of tangent lines to the graph. Tangent, what is it tangent to? Tangent to the graph of y equals f of x. And the information that you can either get about what the derivative looks like based on the graph, or if you know the derivative, what that tells you about what the graph looks like. That is what we're going to work with and practice today. And so using this idea, we have when f prime of x is greater than 0 on an interval. So what they're talking about here is on an interval from, say, -5 to 7 for our x values. F prime is always positive for on that interval. This tells you that the slopes of the tangent lines are positive. So we have f is increasing on that interval. And it's because we have the situation, we have positively sloped tangent lines. Likewise, when f prime is negative on an interval, again, we can think of the idea of slopes of tangent lines. When f prime is negative, that means we're going downhill. The slopes are negatively sloped. And on that interval, then, f is decreasing. On that interval. And so we have, and it's because we have negatively sloped tangent lines. Okay, so we have greater than 0, we have less than 0. What's left? When f prime of x equals 0 on that interval. When f prime of x equals 0, that means the slope of the tangent line is 0. We have a horizontal tangent line. And if it's equal to 0 on that whole interval, that means we've plateaued, so to speak. The curve is plateaued. And we have f is constant on that interval. it's constantly at the value of 100, or it could be at the value of negative 100. This doesn't tell you. It just tells you what the shape is. It doesn't tell you where. Last thing we want to talk about is if f of x has a sharp corner, or we could talk about maybe a hard edge to the graph. What happens when that occurs? F prime of x is undefined there. Let me draw a picture of what we mean by that. So we may already be familiar with some graphs that look like that. For instance, an absolute value graph. We have a sharp corner right at the V. And even if it were upside down like this, one way to think about it, what would the tangent line look like there? Tangent lines really don't make sense at that spot. Mathematically, we would talk about the fact that if we were looking at the table of values, like we've done before, for values a little bit below this point, we would approach some number, and a little bit above. They wouldn't both approach the same value. So we wouldn't know what we could guess or estimate for our value of f prime there. You could have pictures that look like this. And again, the derivative doesn't make sense at those spots. Let me circle those. What do I mean by hard edge? Another graph we might be familiar with is the square root function. It has a hard edge right at that spot. Again, what does the tangent line look like at that spot? It doesn't necessarily make sense. So the derivative right at that spot doesn't exist. It's undefined there. So what we're going to do is we're going to gather this information and either look at graphs of derivatives to be able to tell us information about the function, or looking at graphs of the functions to be able to tell us information about the derivative. Keep in mind, this tells us a general shape, but it doesn't tell us where. Similar to our lines for slope. The slope being 3 tells us we have a shape that looks like this, but it could be down here, it could be up there. We don't know without other information. Okay, so we want to talk about derivative of a function, f prime of x. And we saw before what the definition of f prime of 2 is. Now we want to know what the definition, not the interpretation, of f prime of x is. And it's similar in that we're looking at the limit as h goes to 0 of f of x plus h minus f of x all over h. And if we could figure out this fraction is called the difference quotient. And what those are is these are slopes of those secant lines that we've talked about before. The change in y's over the change in x's. If you're thinking of these as the two x coordinates of the points on the graph, and then the x plus h and the x, so this whole thing, those would be the y values. So we'd have slopes of the secant lines. And as those 2 points on the graph get closer and closer to each other, as h goes to 0, those lines get closer and closer to a tangent line. So this ends up being f prime of x. So what we can do is we can do tables like we did to figure out what f prime of 2 was, or various things like that. And what we'll learn later on is how to come up with these formulas in general. But right now we're going to talk about what the idea of f prime of x is and what this tells us about the function.